Right, welcome students. In the today's discussion, I'm going to talk about uh, how to make a graph for the given adjacent matrix. So adjacent matrix will be given, and we must make a graph for that. That's what we are going to see. Now look at that. The adjacent matrix is given to us. Take for example the adjacent matrix of a graph G is given as uh, 0 1 0 and then 1 0 1 then 0 1 0. This is one of the university question which is asked since 2020 September October exam, I think so. So it is better that to discuss this at this time. So the matrix, adjacent matrix of a graph G is given to us, and what we have to find is the corresponding graph we have to find. The first step is we have to give the vertex name for the first column, for the second column, and for the third column. Similarly here for the first row, first vertex, second row, second vertex, and third row, third vertex. So totally how many vertices are here? 3 vertices are here. So let me take those as a vertex now. Okay, now vertex 1, vertex 2, vertex 3. So 3 vertex I have taken here, and vertex 1 I have taken this, vertex 2 I have taken as this, and vertex 3 I have taken as this particular dot or point. Now you look at that. If this vertex is very adjacent to this, then 1 will come here. I mean, take this matrices V1 and V2, the intersection is 1. That means V1 and V2 are adjacent. If V1, take V1, they are not adjacent. V1, V3, 0 comes, no adjacent. So wherever 1 comes, we must make an edge between the 2 vertex. If 0 comes, we should not make an edge between them. Take for example V2 is there, but there is no adjacent vertex. V2, V3, 1 adjacent vertex. So 1 is there. We have to make adjacent. I mean, we have to make an edge for that. Now come to this V1, there is no adjacency. V1, V2, yes, 1 comes here. Look at that, 1 comes. Therefore there is an adjacency. So we have to make an edge between these two. Then V1, V3, there is no adjacency because 0 comes. V1, V3, there is no adjacency. V2, V1, yes, 1 comes here. There is an adjacency from here to here. That is already we have drawn. V2, 0. So V2 we cannot join. V2, V3, there exists an edge. There is an edge between V2 and V3. So V2, V3, we have to make a connection. This is one edge, this is another edge. Now V3, V1, there is no connection. V3, V1, there is no connection. And V3, V2, there is a connection. V3, V2, there is a connection already. And V3, V3, 0 comes, there is no connection. Between V3, V3, there is no connection. So this is the corresponding graph for which the adjacency matrix of G is this. So you must practice with if graphs are given, you must be able to make an adjacency matrix like this, or if the adjacency matrix is given, we must be able to make a graph for that. So the corresponding graph for this matrix is this, and for this the corresponding matrix is this. Thank you very much. Okay, welcome students. In today's class I am going to talk about what is an Eulerian graph. What is an Eulerian graph? That's what today I am going to talk about. Okay, now look at the screen now. Now let me take this. What is an Eulerian graph? Now what is an Eulerian graph? Now look at the screen now. There are four vertices I have plotted on the blackboard. I call it by V1, V2, V3 and V4. Now I am going to make an edge between each vertices here from V1 to V2, and then from V2 to V3, V3 to V4 and V4 to V1. The similar way I am going to make another picture whose vertices, again there are four vertices, and I make an edge, and before that I name the vertices as A, B, C and D. Now again I am going to make edges as follows: from A to B, and from B to D, and D to C, and C to A. Now there is a speciality in these two pictures, or two graphs we say. Actually it's not pictures, it is graph. So any graph is nothing but a group of vertices. Vertices joined by edges is called a graph. So two graphs we have here, the first graph and the second graph. Now there exists a speciality in these two types of graphs. What is that speciality? Now I am going to make a cycle from V1 to V2, V2 to V3 and V2 V3 to V4 and again to V1. Now let us make the cycle now from V1 to V2, from V2 to V3 and from V3 to V4 and then from V4 to V1. Okay, again look at that, how I am making the cycle starting from V1 to V2, then V2 to V3, V3 to V4 and V4 to V1. This is a cycle. You note what type of cycle is this? What type of cycle is this? So in this cycle, each edge of the graph is each edge of the graph. This edge, this edge, this edge and this edge comes only one time. Have you noted that? So this is a cycle in which each edge comes only once. Am I correct? Now look at the other picture, this graph. Again I am going to make a cycle starting from A ending at A. I am going to have from A to B, then B to D, then D to C, at last from C to A. I am going to make a cycle now from A to B, from B to D, from D to C, and lastly from C to A. What do you see again? This is a cycle, okay, such that each edge comes only one times. or other way I can say is that this cycle contains each edge only one time. Look at that, AB only one time comes, BD one time, DC one time, and CA one time. So this is a cycle such that it contains each edge of this particular graph only one time. Let me try it. Now look at that again. Okay. Now look at that. A to B one time, B to D. The edge comes only one time. D to C edge comes only one time, and C to A edge comes only one time. So you have to understand that in these two pictures there exists a cycle such that the cycle contains each edge only once. Am I right? I mean, the cycle passes through all the edges but only one time. Such a special type of graph, we call it as Eulerian graph. So the definition goes like this. In a graph, if there exists a cycle such that it passes through all the edges of the graph but once. Okay, now look at that. In a graph, if there exists a cycle such that that contains each edge only once, each edge but once, and such a type of graph we call it as Eulerian graph. Such a graph we call it as Eulerian graph. Thank you very much. Yes, it is really happy that today I'm going to talk about another topic. Okay, today. In the previous day we talked about what is Eulerian graph. It is a graph in which at least there exists one cycle such that contains each edge only one time. Such a graph is called Eulerian graph. Now let me take another definition, and that is what is Hamiltonian graph. What is Hamiltonian graph? That's what we are interested in. Now look at the screen. This is a graph, definitely, because it consists of vertices as well as edges. Vertices as well as edges. Therefore, definitely, it is a graph. Now look at that. This is another graph because it consists of vertices as well as the edges. The vertices are joined by the edges. Now let me name the vertices A, B, C, D, and E. So in the first picture there are 5 vertices and 6 edges are there. Now let us take the second picture. I call it the vertices by V1, V2 and V3. V1, V2 and V3. V1, V2 and V3. Let me give V2 and V3. So this is also a graph because consists of 3 vertices and 3 edges. Okay, now what is a speciality in these two pictures? Okay, in the previous case let us take that. In the previous case, the speciality is that the cycle passes through all the edges but once. This is one edge, this is another edge, this is another edge, the fourth edge. So the cycle passes through only one edge. Similarly here, the cycle passes through each edge but once. Now look at this graph now. Now look at that. What do you see? Now I am going to make a cycle again from A to C, from C to E, from E to B, and then from B to D, and then again from D to A. Now what you see here is that when I draw this particular cycle starting from A to C, C to E, E to B, and B to D, and D to A, each vertex comes only one time. This vertex comes only one time, this vertex comes only one time, this vertex appears only one time, and this vertex crosses only one time, and this vertex appears only one time, and this also appears only one time. So all the vertices A, B, C, D, E, all these vertices appears only one time. I mean, there exists a cycle in which each vertex covered but only once. So this cycle covers each vertex but only one time. Okay, now look at again. First vertex A, second vertex C comes only one time. Now E vertex comes only one time, and B vertex is reached and it is only one time, and D appears only one time on the way, and A appears only one time. So this is a cycle in which all the vertex lies but only once. Okay, in the similar way this picture also. Now look at that. From V1 to V2, so V1 comes only one time, V2 the second vertex comes only one time, and V3 crossed, and that is only one time. Now next one, V1 comes only one time, and again it reaches where it starts. So it is a cycle starting from V1, then V2, then V3, and V1. So all these cycles, note the vertex, appearance of the vertex. Only one time in the cycle the vertex V1 comes. Here V2 only one time, V3 one time. So this kind of graphs where there exists one cycle such that each vertex appears but once. The cycle crosses each vertex but once. Similarly, the cycle crosses each vertex but once. This is a speciality in these two graphs, and this type of graph we call it as Hamiltonian graph. So what is our understanding is that in a graph, if there exists a cycle such that each vertex appears once, then that graph is called Hamiltonian graph, and that suits for these two graphs. Okay, so I repeat again, a Hamiltonian graph is a graph where there exists a cycle which passes through all the vertices but only once. So the definition goes like that: in a graph, if there exists a cycle such that, now look at that, Look at that. This is what we have here, the definition. What is a Hamiltonian graph? In a graph, if there exists a cycle such that the cycle passes through all the vertex but only once. There are two conditions. The first condition, the cycle should passes through all the vertex. First condition. Second, each vertex should lie only one times. The cycle should passes through all the vertex only one time, not more than one time. Such a graph we call it as Hamiltonian graph. Thank you. The next class I will come with another topic. So what is now I'll tell you what is complete graph. What is complete graph? Now look at that. This is the graph that I would like to explain to you. This is one vertex like this. You can take this. Now what we see here is one vertex here, another vertex here, another vertex here, another vertex here, another vertex here. Now let me join these two vertices also, these two vertices also. Now let us start. You see here what he was saying is that V1 is vertex, this is V2 vertex, this is vertex V3, this is vertex V4, and this is V5. Now in this picture, what is speciality? Each and every pair of vertex Vi and Vj. So you take any two vertices here, a pair of any vertices on this particular picture, it have the edge. That's what we have to see here. This is have edge. V1, V2 have an edge. V2, V4 have an edge. V3, V4 have an edge. V3, V5 have an edge. V1, V4 have an edge. So all the pair have edge. So such a graph we call it as a complete graph. So complete graph means each and every pair of vertices in this graph we should have an edge. Okay, so if each pair of vertices in a graph if vi vj in a graph or adjacent means there must exist an edge between them. That's called adjacent. So graph or adjacent, then this graph is called complete. Then it is complete graph. Then it is a complete graph. A complete graph. So come to the conclusion here. A complete graph is one where each and every pair of the vertex in the graph, each and every pair of vertex in the graph have an edge. As if vi vj in a graph or adjacent to one another, that means they have the edges, then we say it is complete graph. Thank you very much.